Bismillah ar-Rahman ar-Rahim. Welcome to Lady Khadija radiallahu anha online college. May God be pleased with her. Live lesson A-level maths, year 2, pure maths. Today we're looking at the sum of a geometric sequence, otherwise known as a geometric series. If you're following through in the Edexcel Pearson book, it's chapter 3, example 13. So hopefully you got the idea of what geometric sequence is. It's a sequence where the number goes to the next number by some kind of multiplier, and then to the next number using that same multiplier. So you're multiplying by something every single time, and the first number is called A, the multiplier is called R for ratio. So you've got the basics hopefully. If you want to work out any particular term, so the 9th term or the 10th term or the 100th term, then the formula you need is A times R to the power n minus 1. So A is the first number in the sequence, R is the ratio, the multiplier, n is the number of the term you're looking for. So if it's 10, you're looking for the 10th term, 10 take away 1 would be a power of 9 here. So that will work out a particular number in the sequence. But what if you want to work out the sum of the whole sequence? Then there is a formula that you need to learn, which is the sum of a geometric sequence is equal to, and this one is a little bit hard to keep in your head, but it starts off with A, which is easy to remember, and then in brackets you got 1 minus R to the power n, and then close the bracket. And then on the bottom, you've got just 1 minus R. So that's one formula, and there's another formula where we can swap the inside of the bracket around, so we can put the R to the n first, then take away 1. As long as we do that to the bottom as well, that would be R take away 1. But we're just going to stick with this formula. Which way around which formula you use, it depends on how big R is. It's sometimes easier to use one compared to the other, but if you just stick with this one for now, so let's see if we can use that. We're going to need that. You're going to need to memorize that if you want to work out the sum of a geometric sequence. So let's stick that here. So let's take a look at this example, example 13. Let me just remind myself what it is, what the numbers are. So you got 2, 6, 18, 54. 2, 6, 18, 54. That's the numbers in the sequence, and the sequence carries on for 10 terms, and we want to work out, well, if we added up all those numbers, what would it be? So let's start with the basics. Let's try to work out what A is, what R is. That's where you've got to start with. And A is very easy. It's just 2, the beginning number. To get R, you have to pick a pair. So let's pick the first pair and do 1 divided by the other. The second one divided by the first. So 6 divided by 2, that makes 3. So it looks like R is 3. But just to make sure we didn't get this wrong, because if you get R wrong, you're going to get the whole thing wrong. So let's pick another pair. Let's go with 6 and 18. So 18 divided by the 6, well, that makes 3 again. So we're happy with 3. And now we want 10 terms, so n is equal to 10. And let me just check. It is 10 terms. Yep, it's 10 terms in the question. So let's grab the formula for the sum. And let's see what goes where. So your A will be 2, your r will be 3, your n will be 10, and at the bottom here, your r is going to be 3. So if we put those into the formula, we will get 2 times 1 minus 3 to the power 10. And here you can see straight away that that's going to be a very big negative number. So it's probably better we use the other formula with the inside of the bracket the other way around. But rather than memorize two formulas, just go with one, and I'll stick to this one. So 1 minus 3 on the bottom is going to be minus 2, so I might as well put minus 2 there. Straight away I can see the 2 divided by minus 2. That's going to cancel to just 1 minus 1 on the bottom, so or on the top, it doesn't really matter. So 2 divided by 2, that's going to cancel to just 1 over 1. So 1 divided by minus 1 is just minus 1. Let your calculator do the hard work. So let's type that in to the calculator. So on the top, and I just want to make that minus. Rather than have the minus at the bottom, you can bring that minus to the top. And 1 divided by 1 is just 1, so we don't really need that anymore. So we can rub that out. And there's nothing on the bottom now. So we can take that away and take that away. And then we've got this. Okay, so let's type that in. We've got minus. Now this calculator isn't as good as a normal scientific calculator, so I'm just going to do it slightly differently. I'm going to do 1 take away 3 to the power 10. So just doing the inside of the brackets first. That's minus 59048, and then I just need to times that by a minus. So the minus is going to drop off. So 59048. On your calculator, just type it in as you see it, and you should get the same answer, 59048. And that's it. That's how you work out the sum of a geometric series, sum of a geometric sequence, otherwise known as a geometric series. Let's do another example just to make sure that you're completely comfortable. So this time notice that it's slightly harder because we don't know how many numbers there are going to be. So we've got, let's write it out. We've got 1024 as the first number, that's your A. We've got minus 512, we've got 256, we've got minus 128, and then it's going to end. The sequence is going to keep on going, but in terms of this, how many we want to add up, we want to keep going until we get to 1. Now is that 1 here the 10th term, the 15th term? We're going to need that because that's going to go here as our n. So let's do the easy things first. We've got A is 1024, the first term. Let's work out what R is, the ratio. So it looks like if I take this number and divide it by the previous one, I'm going to get minus 0.5. Let's just double check that. So I've got minus 512. Let me just clear the screen. So minus 512 divided by 1024 minus 0.5. If I just check with the next pair, 256 divided by minus 512, that didn't quite work out. Let me try that again. 256 divided by minus 512 is minus 0.5. So that's great. So we can say that R is minus 0.5. Now, can you think of a way of working out how many numbers there are going to be in the sequence I'm trying to add up? There isn't really an easy way. You're just going to have to take the formula for the nth term of a geometric sequence. So that's A, R, and hopefully you remember the end bit is n minus 1 to the power n minus 1. Looking at the last term here, 1, we know that this is going to give an answer of 1. We know our A is 1024. We know our R. We don't know what N is. So let's put in what we do know. A is 1024 times by R, which is minus 0.5. And then we've got N minus 1 to the power N minus 1 is equal to 1. And we've got to solve that to figure out what N is. Not an easy equation to solve. You're going to have to use logs here, but let's try and make life easy. Let's bring the 1024 to this side. So I've got 1 divided by 1024. I don't need the brackets now. Next, this is where we're going to need to use logs now. So if you remember how it goes, we're going to take the log of both sides. Just like you take the square root of both sides sometimes, let's take the log of both sides. So we're going to apply a log to this side on the left, and we're going to apply a log to the right hand side. If you don't know what log means, then just think of it as a button on your calculator for now, just like square root. But it's to do with powers. So now we've got taking the log of both sides, we're applying log to both sides. And now what can happen with logs is there's something called take down the power rule, a rule known as taking down the power. So what we're saying is that if there's a power after the number, which is the number we're taking the log of, then if that power can be brought down to the front, and that's just n minus 1 at the front now. So let's just write n minus 1 at the front. So it's no longer a power now, we brought it down, which is great. So that means I can divide both sides. I can take the log minus 0.5 to the other side. It's a little bit messy on this side because I've already got a log and a fraction there, but your calculator will be able to handle it. So I'm just going to take this to this side, and I want to isolate the n. So I'm just going to take the minus 1. Firstly, remove the brackets because there's nothing on the outside of the brackets, and then minus 1 can go to the other side as a plus 1. And then it's just a question of typing that all in. You should be able to type it in one go into a scientific calculator, and then you'll figure out what n is. So let's try that on this one. If it works, I'll be very, very surprised. So on the top, I've got log. There we go. So log. No, on this calculator, it wants the number to work out the log of first. So let's give it that. So I need the log of that. And then I want to divide that by minus 0.5 and the log of that. That's not working, so let's try another way. Okay, so with logs, you shouldn't. It's important to know that you can't take the logarithm of a negative number. So that's a slight problem. So that means something's gone wrong on this one. Let's see what's gone wrong. Okay, so starting with the nth term formula, first 1024 for your A, minus 0.5 for your R, and n minus 1 for your power is equal to 1. And then we want to divide by 1024. And then we want to take the log of both sides. Okay, so then we're going to get a problem here. So somehow we want to get rid of that, which is a bit of a pain. So how are we going to get rid of that? We can remember that minus 0.5 is equal to minus 1 times 0.5. So if I rewrite that as minus 1 times 0.5 and put that in brackets, then we can take the power of n minus 1 and apply that to each bit. So the n minus 1 gets applied to the minus 1, and then it gets applied to the 0.5. A bit like if I said I've got 4 times 2 squared, then that would be the same as if each bit was being squared. 4 squared times 2 squared. So same principle here, the power can be applied to each bit. So then that would mean I've got minus 1 in brackets to the power n minus 1 times by 0.5 to the power n minus 1. And that's equal to 1 over 1024. Okay, so just a little bit tricky, that step where I split it out, but that's because I needed to avoid anything negative in the brackets, because when I do the logarithm of a negative, I'm going to get an error, as you saw earlier. So now I've split that out. Here you just got to realize that minus 1, when you raise minus 1 to any power, then you're either going to end up with minus 1 or you're going to end up with 1. So for example, minus 1, if I raise that to the power 1, then I'll end up with minus 1. But if I raise that to minus 1 squared, then I won't have a minus, I'll just have 1. And if I carry on like that, if I raise it to the power 3, then I'll end up with minus 1. So it'll either be minus 1 or 1. And because we're looking at the number 1 being the answer, and that's positive, then even though I don't know what n is, I know that minus 1 raised to some power is going to end up as a positive. So I can, as a positive 1, so I can just delete that. That's probably worth taking a minute or two just to think about, but just to repeat in case you're confused, minus 1 to any power, if I just put question mark, I don't know what the power is going to be. It's either going to be as an answer minus 1 or it's going to be 1. It doesn't matter what the power is. You could raise it to a power of 1,000 or you could raise it to the power of 1. These are the only two possibilities. It's either going to be minus 1 or it's going to be 1. Whatever power it's going to be. Which one is it going to be? We don't know because we don't know what the power is, but if we take a sneak preview of the answer is a positive 1. So that means that to get a positive, I'm going to have the 1 as my answer. So even though I don't know what the power is, I know that my answer is going to have to be 1. So I know that that minus 1 that was here to the power of n minus 1? The answer to that has to be the 1 rather than the minus 1. So since it's 1, I can just leave it out altogether. So now I can go ahead and do what I did before, which is take logs. So take a log of this side, take a log of the other side. And since you've seen this before, you should be able to guess what comes next. Once you apply log to both sides, what does come next? It's called bringing down the power. So this n minus 1 power here, we're just going to bring it down, and it's going to come to the beginning of the log. If you're new to that concept, then you have to revise a little bit of your first year logarithms. So there's your n minus 1. I'm just going to rewrite that so it's nice and big because it's no longer a power now. And then think about how do I get n on its own? Well, I've got log 0.5, which I'm going to bring over to this side. So that's going to be a divide by log 0.5. And then the brackets I can drop. There's nothing outside of them. So the brackets I can drop. The minus 1 can go to the other side as a plus 1. And that'll leave me with just n, as long as I take that minus 1 across, and it will turn into a plus 1. And now I've just got to type that all into the calculator. Your calculator will hopefully be easier to use than this one, but there's your 1 over 1024. Let's take the log of that, and then let's divide by log of 0.5. And then let's add 1, and we get 11. So it's the 11th term that we need to go up to in the sum. So there's your sum formula. There's your A, there's your R. We now know what n is. It's 11. So let's stick that into the formula. So let's bring the formula down. So you've got A as 1024. Your n is 11. Your R is minus 0.5, so just be careful about that. And your R at the bottom is also minus 0.5. So you should be able to type that all straight into a calculator. A scientific calculator would be able to handle that all in one go. So let me see how I do with this one. So 1024 times by, and then in brackets, 1 minus, and then I've got in another pair of brackets, minus 0.5 raised to the power of 11, and then close that bracket. So that gives you 1024.5, and then I need to divide that by the denominator, which is 1 minus 0.5. So that's going to turn into a plus. So that works out to be 683. Just double check that I haven't made a mistake by going to the worked example in the book. And there you go, 683. Okay, join me for more work on geometric sequences next time. Assalamu alaikum wa rahmatullah. Peace be with you, and the mercy and blessings of God.